Okay, I wanted to do some more logarithmic differentiation problems with you. So I'm looking at the handout for 3.5, and I thought I'd go ahead and just do all of the problems that were on there. Okay, so this one right here. All right, what makes me want to do logarithmic differentiation is, even though I could do it otherwise, the fact that I've got the quotient rule and each item in the numerator and denominator is really raised to a power kind of makes it a little bit of a mess to try to take care of. Okay. So what I'm going to wind up doing is using this idea. I'm going to come in and I'm going to do the natural log of both sides first. Okay. And then since I now have, let me go ahead also and rewrite that denominator as that raised to the 1/2 power. Okay. All right. And then these conditions and all that you'll see, you can pretty much just ignore those. They typically have to do with domain issues and that kind of thing. All right. So once we have done the natural log of both sides, what you want to do is take a little bit of time using the log properties to rewrite the expression on the right-hand side. What you're going to do is expand it, and you're going to be doing that using these properties right here that tell you what happens when you have the log of a product, right? It turns into the sum of two logs. Log of a quotient turns into the difference of two logs. And then if you have the log of a power, you can bring the exponent down in front. So what I'm doing right now is not yet taking the derivative. I'm just using the log properties to expand this expression. So since it's a quotient, I could rewrite it using subtraction, rewrite it as the difference of two logs. Okay, and then notice I have a power expression raised to a power on each of these, so that there's a property of logarithms that allows you to bring the exponent down in front. I am not doing the power rule. I'm not even doing derivatives yet. I'm just using the fact that this expression would have the same meaning as what you see above it. Okay, and then over here on the left is lny, not just y. All right, now when I get to there, what I want to do here, I'm going to probably need a little more paper. Okay, is go ahead and do the logarithms. Do the derivative. So I'm going to use a wavy line here to indicate to you that below this line is when I'm starting to do the derivatives. Now, on the left-hand side, when I do the derivative of lny, the natural log of y, I have to I'm really using explicit differentiation. Remember that y is a function of x. So when I do the derivative on that left-hand side, yes, I'll think of it just like a derivative of a natural log would be 1 over your input, but don't forget that y is a function of x, so you need to do the derivative of it. Okay? All right, and then here, that's a constant 2. I have natural log. I'm going to do 1 over x minus 2. But then the derivative of the inside function, okay, there the derivative was y prime. Here the derivative of the inside function would be 1. Then here I'll get 1/2 times 1 over x squared plus 1. And when I do the derivative of the inside function here, I do get something. I get 2x, okay? All right. Now I've done the derivatives. Now I'm just trying to get this consolidated so it looks better. Okay, so now I'm going to rewrite this as 2 over x minus 2, because that 2 right there is really 2 over 1. So the way fractions work, when you multiply straight across, you get 2 on top. Here, the 1/2 times the 2 would just be 1. So I'm going to have minus x over x squared plus 1. All right, and then over here, let me just bring this down. I haven't messed with it yet. All right, now I'm going to wind up having you or allowing you to not fully simplify on these logarithmic differentiation, because they can be really nasty. This one's not too bad though, so I'll show you where I'm going to let you stop on the test, but this is really not that bad. So I'll also show you how to finish one. All right, so what we'll do here is we need to get the y prime by itself. So I'm going to multiply by y, which will knock that out. But if I do that on the left, I have to do that on the right. Okay. And then what I'm going to do is I'm going to replace y on that right-hand side. Right there where you see the y is, I'm going to replace it with what we had here in the beginning. I have to go back and look at it, look for it. See, we know what y is. We know y equals this right here. So I'm going to rewrite this now. I'm going to replace it with the original problem, which was the y was equal to x minus 2 squared over the square root. Let me keep it with the fractional exponent for a minute, though, because I might be doing some simplifying, and it helps to have it with exponents. So I just replaced the y with the what it was equal to from the beginning, right? That right there. All right, on the left-hand side, I just have the y prime. On the right-hand side, I still have this 2 over x minus 2 minus x over x squared. Let me spread that out a little more because of what I know I'm about to do. Okay. Okay, and it has a minus in there. Okay, so now what I'm going to wind up doing here is that's what I'll allow you to stop at right there. Getting the y by itself, the y prime, I mean, by itself, and then having everything else on this side. And these right here can sometimes be, there can sometimes be several of them. And so it can be a challenge to get those fully simplified. But I'm going to go ahead and show you what you would do. Okay, so I'm just going to copy this down. And right now I'm working on the simplifying step, which we really should do, but we sometimes don't because of how labor intensive this part can be. So what I'm going to wind up doing is getting a common denominator on these two fractions. So I have an x minus 2 here, and I have an x squared plus 1 there. So I need an x minus 2 and an x squared plus 1 on each of these. So on the first fraction, I would have to get a common denominator by multiplying top and bottom by x squared. Oh, darn it. I didn't want all that to go away. Oh, well. I'll get it back where I want it. I'm just trying to erase that one little line. And here, x minus x. Okay. Okay, so what I'm doing is getting a common denominator. So I multiply the first fraction by x squared plus 1 top and bottom, and the second one I'm going to need to multiply by the x minus 2 top and bottom. Okay, so that's going to give me a common denominator. So I'm going to have 2 times x squared plus 1 minus x times x minus 2, and all of that is now over this common denominator. So to add fractions, you have to get a common denominator. So it can be a challenge when they're algebraic fractions. It's not too bad, though. You can handle it. So now we're going to distribute. Here, there's a negative in front, so I'm going to distribute the negative as well. So I'm going to have an x minus 2 squared. Down here, an x squared plus 1 to the 1/2 power. Here, I'm going to have 2x squared plus 2 minus x squared plus 2x. All of that over x minus 2, x squared plus 1. A lot of it's just being willing to take the time to show your work to yourself. That helps a lot. Okay, so now what I'm going to do is combine like terms. So these are like terms, and I'll wind up with x squared, then plus 2x plus 2. In the denominator, I have the x minus 2, x squared plus 1 still. And then over here, I have an x minus 2 squared, and I have that x squared plus 1 to the 1/2 power. All right, so the last thing I'm going to do to clean it up is I'm going to notice that there's an x minus 2 top and bottom. So I can knock out one of the x minus 2s. So that'll leave just one x minus 2 on top, right? So I'm going to knock out one of these. That's leaving me just one. Then I also notice that these two expressions have the same base. So let's consolidate those, and that would be x squared plus 1. This is 1/2. This exponent is 1. That's 3/2. Okay. And then I still have this x squared plus 2x plus 2. That really doesn't factor, though. It's not x plus 1 times itself, because you would have had a 1 at the end. All right, and then finally, I'm going to put the radical back in there. Okay, and you'll sometimes see them not do that when it's a higher exponent, when it's got the top number. Sometimes they don't go back to radicals, but I'll go ahead and show you that. So it's like x squared plus 1 and all that to the third power. Okay. All right, so again, I'm going to allow you to stop. Okay, here, where is it? I'm going to back up. See, a lot of that was simplifying. I'm going to let you stop here, right here, okay, before I get common denominators. So ignore the red part. Okay. All right, so I may go all the way and simplify a few more just so you see the idea. But on the test, I'll definitely allow you to stop without getting your rational expressions rewritten as one term. All right, so let's do another one. So this is the second problem. That's an x squared plus 4, okay. All right, so this is a good candidate because I got, factors on top here, I put in that little times, got things raised to powers. Maybe it would work out nicely to go ahead and natural log both sides. Of course, they tell you to do it, so you would definitely do it. Okay. All right, so now I'm using the log properties, and that allows me to take the numerator, which is x squared plus 1 to the 4th power times e to the x, and then have the natural log of that minus the natural log of the denominator. So that's the quotient rule for logarithms. Okay, then this is a product here. So I can use the product rule of logarithms to rewrite that as the sum of these two. I can't separate the natural log of x squared plus 4, though. It is not true. It is not equivalent to natural log of x squared plus natural log of 4. Okay. See, these log properties, I didn't want to really get into it too much, but if you're trying to make sense of why this is, logarithms are really exponents. They're the exponent you need on a certain base in order to get a particular number. So they're related to the rules, shortcut rules for exponents, like x squared times x to the 3rd, the shortcut. Even though we're multiplying the powers, the shortcut is that you add. Or how when you have a quotient, 2 powers with the same base, and you're dividing, the shortcut is that you could subtract. That's kind of the idea behind a product turning into a sum and a quotient turning into a difference. It's because logs are really exponents. All right, now there's another rule that we can use, and that is to bring the exponents down in front. So this exponent, we have a power here. This can be brought down in front. Now, I can also bring the x down in front, but natural log and an exponential function with a base of e, these are inverse functions here. So this term right here is going to turn out to be just x. E and natural log are inverses, like adding 5 and subtracting 5. So you get back out of that your input. Right now, you might be more comfortable if I go ahead and bring the exponent down, like I'm going to do here. And you can think that, okay, it's just the natural log of e is really, if you do that, you'll still find that you get just x because this turns out to be 1. And you can do that on your calculator. Do ln of e and you'll see what I'm talking about. Okay, so you either just write an x right there right off the bat for this because you know they're inverses and they undo each other, or you bring the exponent down and then you put a 1 where ln of e is. All right. Now at this point I need to stop because this is a sum, so I can't separate it and I can't pull just the 2 out in front. Okay, let me bring that ln of y back down on this side. Okay, I have not even started doing derivatives. That's just using my log properties to expand these expressions. And when you get the hang of it, you really just jump, you really kind of start, your first step would probably be this guy here, and then you'd bring the exponents down. All right, so now below this line, I'm going to start doing the derivative. So the derivative of a natural log is 1 over your input, but then you have to multiply by the derivative of the inside function. Okay, so then here I'll get 4 times 1 over x squared plus 1 times the derivative of the inside function times 2x. Here that's really just x, right? This is just 1. So the derivative of x would just be 1. And then on this one, I would get 1 over x squared plus 4 times the derivative of the inside, which would be 2x. Okay, so now we just kind of collect stuff. We have 8x on top. 4 times 2x is 8x over x squared plus 1. And then we have plus 1, then minus 2x over x squared plus 4. Okay, this is 1 over y times y prime. Okay. Okay, so now at this point, I'm going to wind up seeing if I can go ahead and put, let's see, I would go ahead at this point and maybe go ahead and multiply both sides by y. Okay, so when I do that, the y and the 1 over y would equal 1. So I would have the y prime equal to. And then in place of the y, I'm going to put the original problem, which was x squared plus 1 to the 4th e to the x over x squared plus 4. Okay, so that's where the y is. And then I have this. I have the 8x over x squared plus 1. I'm going to go ahead and put the 1 at the end. 2x over x squared plus 4, and then plus 1. Okay. All right. Okay. All right. Now what I'm going to do is first let you know that on the test, that's where I want you to get to. You don't have to take the time to consolidate this into one term. I'm going to finish it since I have the time to finish it. So let me go ahead and finish that. This is the simplifying. So what I'm going to do is look for a common denominator. So this one would have to get multiplied by x squared plus 4, top and bottom. This one by x squared plus 1, top and bottom. And then this, the 1 would have to get multiplied by x squared plus 1, x squared plus 4, top and bottom. Okay. All right. So I wind up then with y prime equaling all this. What's that? E to the x up there. Then here I would have, and I'm going to go ahead and get my denominator written. So it's the x squared plus 1. Don't ever multiply it out, though, because you're going to hopefully have stuff that'll cancel. Then on top, can we go ahead and distribute as I write this? That would be 8x to the 3rd plus 32x. and then minus, because it's a negative here, minus 2x to the third minus 2x. And then that last little piece right there, that has two binomials, so I have to multiply that out. That would be x to the fourth. Then I'd have plus 4x plus 1x, which would be plus 5x squared, and then plus 1 times 4, which would be 4. All right. And so then I'm going to bring this down one more time. I'm going to see what happens up on top. So I have an x to the fourth. Then I have 6x to the third. Then I have a 5x squared. And then 32x minus 2x would be 30x. And then plus 4. Okay. Then here I have an x squared plus 1 and an x squared plus 4. Okay. All right. And then I'm almost done. I'm just going to notice that I can knock out one of the x squared plus 1's, making that just 3 of them up there. And then I can put this together with that and get x squared plus 4 to the fourth. And so I wind up with x squared plus 1 cubed. I have an e to the x. Maybe I'll put that out in front so I don't lose it. And then I've got all this. Now this could potentially factor, but factoring something to the fourth power, you would have to actually use all your polynomial skills. So there might be a slim chance that that would factor and maybe something would cancel out, and we're not seeing if that's the case. We're kind of stopping at this point. At least we got it to be a single factor. At least we got this to be consolidated into a single term. Okay. All right. I don't like my videos to get real long, so I think I'm going to stop that one, and then I'll do the last two problems in a separate video.